So by now I expect that although the definition, although the aspects of CFD, entire CFD is yet to be explained, yet to be discussed, I just expect that by now you have figured out that there is something called CFD, which is different than experimental method and theoretical method, and that something called CFD is preferable over these two methods uh, because of those uh, reasons that I already mentioned. So just at this point of time, we'll just consider CFD at something which is better than these two, and that can be used for in equivalent of these two methods for analysis. So now let's again go back to our this problem of structure. This is not a CFD problem, this is a structure problem. So this structure problem, if it was simple like this, then we would have applied the analytical method, and as I already told, for this analytical method is not preferable, you have to apply the structural computation method. So that is called, the specific name is called finite element methods. So if we apply the finite element methods, then something like this result we can obtain. Something like this is the final result. This is equivalent to that car, flow past that car that I saw earlier in this video. So this is the deformed process. This both of the figures, they are different, and they are just the representative images. So here we can see the variation of stresses in the deformation, especially that this is the variation of deformation that we can obtain from the finite element methods. It is the computational method. So this type of process by computational method we can solve, and we can arrive to this solution. Similarly, this problem in IC engine, as I told earlier, is the variation of parameters like the fuel, like the density, the temperature of the fuel, the composition of the fuel. If those parameters are altered, what will be the overall efficiency? How will be the flow of air and fuel mixture take place, and what differences can we observe? These things, as I already told, can be done by experiments or by theoretical method. So if we do a numerical aspect, let's say we are concentrating on a particular parameter called equivalence ratio, that air fuel ratio, by changing the fuel. If the fuel is changed, the air fuel ratio will be changed, obviously. So by changing the fuel and by doing the CF, this is proper CFD, unlike that structural problem. By CFD we arrive to this final result. So this final result, we can see the variation of the equivalence ratio. So without doing experiment, without buying engine, without doing the making the setup, simply by modeling and some coding, some analysis, we can do it in our own computer, in our own laptop, or in our own system. So that is the advantage of CFD. So I hope now you are getting some feel of CFD, that what is CFD and how it is done. Slowly you will get more and more. Similar to this engine is some problem like this: the turbine, water is the turbine, and what is the variation of parameters in water, and what will be the equivalent change in the output of the turbine. Similar type of analysis like engine can be done for this turbine, and this can be seen here at the starting of the rotation. This thing, we can see the CFD has been done only at this portion, because it is just the starting, at the starting point of time, starting as of the rotation. So different colors will show the different velocity. This is called a contour plot. So this different velocity fluid particle will strike this Pelton wheel, and it will rotate. So depending on the pressure and the temperature, density, and all parameters of this thing, if we change the parameter, we will get the change in result. So changing parameter each and every time and getting the corresponding result, it will be difficult in experiments. Obviously by now you can only figure out, so obviously it will be difficult in experiment, but in CFD we can do it easily. So now we can explain about how to do CFD. Till now I have explained that where we can do CFD and what CFD will lead to. So how to do CFD? CFD, there are different approaches for that. So So the basic idea of CFD is not to solve the whole of the system. For example, this turbine, we will not we will while doing the analytical method, we may be solving for whole bulk of this water jet striking this Pelton wheel, but while doing the CFD, we will take only elements by elements of this jet, only some finite elements. We'll divide this whole jet of, let's say, some x distance. We'll divide it into some 100 divisions, x by 100, x by 100. So each and every elements of this particle, elements of this part, they will behave differently. Behave differently in the sense they will have some different properties, like different temperature or different velocity or different density. And for each and every elements, we'll apply the governing equations. The theoretical knowledge we know will apply to each and every elements. Instead of applying to whole of the set, we'll just apply to the elements by elements. So that is the main idea of CFD. So these parts are called elements. Elements, basically there are other terms also, we'll go to the details sometime later, and apply the theoretical knowledge of fluid flow to those small parts and elements, and repeat the procedure to each and every elements. Repeat the procedure again and again till it is the accurate solution, till the error is minimized. So we'll be at the first time we are solving first iteration, we'll be getting some error. So we have to compute in such a way that the error is minimized, and for each and every elements. So as I already told, for this set, if we divide it into 100 number of elements, then for each and every 100 elements, we have to apply the governing equation each and every time and again. We have to apply, we have to go on till the error is minimized. Maybe we would have to apply for 100 times into 100 elements, means we have to apply the equation for 10,000 times. So that is the scale of the computation level done in CFD. Just not applying the single equation and getting the answer within 3-4 lines as like an analytical method. This is different. We have to apply for 10,000 times, and 10,000 equations will be solved to get the final answer. So this is CFD. So a process of CFD, as I already told, there will be different approaches. Whether we divide it into some linear elements, then that is called finite elements method. Generally, this finite elements method is preferable to structural problem rather than flow dynamics problem. Although we can apply it into CFD also, but it is preferable to structural problems. Next is finite volume method. Instead of dividing it into one-dimensional elements, we'll take some 3D blocks of elements, some let's say 1 mm cube, or let's say 1 centimeter cube of each and every fluid particles. So these fluid particles, generally called as control volumes, if we do the problem in that approach, that is called finite volume approach. So these things will come under CFD. So under CFD, we will basically concentrate on finite volume method. So what all is studied under CFD? Let's say a ball is falling from certain height, and we are given the initial velocity is 0, and after a certain time t, 3 seconds, we have to find the velocity. So for that, what we need to know? We need to know the physical phenomena. As I already told earlier, physical phenomena is that the velocity, the relationship between velocity, distance, and acceleration due to gravity. That is the physical phenomena. The relationship we get, that idea we will get from physical phenomena. So similarly, this is not CFD. This falling of ball is not CFD. I just showed it to correlate the unknown values with the physical phenomena. Unknown value here is V, and the physical phenomena that is taking place is the acceleration due to gravity. So this correlation we can build. Similar correlation we are supposed to build in CFD. Whether it may be the CFD of flow of fluid within a pipe, or flow of fluid past a car, or flow of fluid past an airplane, we have to extract some knowledge regarding the fluid flow from physical phenomena. So we have to study the physical phenomena first before applying CFD. Finally, CFD. What CFD does? Creativity, obviously, as I already told you, I gave the example of data IC engine. Different variation can be made, and we can do our self-study. We don't need to buy some different fuel some different hydrocarbon, we don't need to buy different IC engine.